while we wait a little bit, what we can do maybe is, I'm taking the dependencies. So, okay, well, let's just stop. I'm happy to reiterate for people when they come back. So this is a little map of stuff we're going to cover. Having gone through it just before this, I think the extra credit items are a little tough. Although you never know, and maybe some people end up further ahead. I'm happy to be happy to go over that. But basically, we're going to go through all of our tooling, what it takes to set up a chain. We're going to join a remote chain all together on the same network. And then we're going to look at a load of the Burrow features that are all in a single Go binary and kind of introduce that and go around. So possibly you'll find we're pretty small number of dependencies, but if you wanted to get on the multiple pages for the depths now. Okay. So we just need Node.js and the Burrow binary. I think strictly we need curl. If you for some reason don't have curl.
And Git.
And Git. Yeah.
So
if you want to go ahead and grab, make sure we've got Node.js that's for a bit later on, but the main thing we need just now is the Burrow binary.
And if you don't have Node.js on your environment, you can, it'll be fine without it. It's a small piece at the end, and you can look over somebody's shoulder. So we have a link up here for how to install Burrow. Is anybody on Windows that doesn't have a Linux VM? Great, perfect, because we don't have Windows binaries. Nothing against Windows, it's just a big hassle to compile the binary. So if you go to the link, you can download for your environment a tarball, extract the tarball, and then within the tarball will be the Burrow binary. I think also the license information, but the Burrow binary, just put that into somewhere in your path. And if we say something along the way here that is way over your head, we have a couple of people around that can help. So don't be shy about asking if you don't know something along the way. And once the Burrow binary is in your path, then just run Burrow -- version to confirm that it is all acceptable. And then we have made a little repository for this workshop, which includes a few small files that we're going to use along the course of this sequence that we're going to work through. So just if you clone that repo right there, cdn to the directory, then we'll be good. So if anybody has any problems along this pathway, just let us know. I'll just pause here while everybody gets the environments set up. This will hopefully be the slowest part of the morning. So, well, there's one more piece, but that is based on YAML formatting and how finicky it is. Is anybody not good? Anybody still working? I see a lot of people looking up. Okay, no worries. Hi, welcome.
So do we have the slides that we shared?
Yeah, I think Alice was tweeting it. We're putting these slides on SlideShare, so if you want to copy and paste any of the commands, you should be able to do it. And the SlideShare is available on the Monax Twitter, which is twitter.com/MonaxHQ. At the top there is the link to the SlideShare. So that'll allow you to copy and paste any of the commands along the way here if you want.
I'm sorry, can I get the slides?
Sorry?
Where do I get the slides?
If you go to twitter.com/MonaxHQ, the link will be in the top tweet there. All right. Anybody else still working? Oh. Now I need you.
Let's turn that on.
That should be about the only time. Okay. Cool. Does anybody not want me to go ahead? I see we have one joiner. You're okay? All right. Basically, we've just installed the Go binary and clone, the Git binary, not Git binary, the Burrow binary, and we've Git cloned that repo. Okay. So where we want to start with is to quickly show you the chain making features and the chain establishment features that we have in Burrow. And so we have typically a 3-step process to run a local network. And we have a specification step where we outline the specification for a network. Then we have a configure line, and during configure what we do is we take a specification, we add some keys if we need to that spec, and then we start the Burrow binary. So if we all start with the first command, Burrow spec, full accounts 1 with a TOML output, pipe that into a TOML file, and then cat that file, you'll see what a Burrow spec looks like. And the specification file is, how do I get to a terminal? So a Burrow specification file, actually let me turn it into TOML. Typically, this is what it should look like here. Let me make this a little bit bigger for everybody. Okay. It includes really an outline of what you want to have your default account be, as well as a few high-level chain parameters, such as a proposal threshold. We're not really going to talk about proposal here. It's a little bit more of an advanced feature. that we are working on fully baking and shipping right now. But the basic idea with the proposal mechanism is that it will allow for things that you want to do on a chain that would be considered kind of root level things. In other words, when you want to change high level parameters of of the configuration of a particular chain, you can run those. You can run that through what we call a proposal mechanism to have a governance mechanism around how you change those high-level parameters of a system. You can also see here how we have accounts that have been set up both in terms of how we want the validators to run as well as how we want the native accounts on the chain to run. So any problems with running Burrow spec into a TOML file? Okay. And if you want to see the full features of what spec can do, this was a relatively straightforward way in doing spec. You can run Burrow spec help, and it will outline for you the various flags and features that you can run into specification. What we didn't show here is that you can use spec if you have developers or specific validators that have specific keys to them. You can add that into the specification file with those public keys and addresses, and then when you run the configure, those keys will be integrated into the Genesis object that the particular chain will use. Okay, so the second step is to run Burrow configure --genesis-spec and to reference the quick spec TOML that we did in the previous step, and then pipe that into quick config.toml. And this is a config object, and a config object looks similar in many ways to a spec object. Where's pipe on your keyboard?
British keyboard.
So, Casey, there's going to be a slight wrinkle with this because we've got a Genesis JSON in that chain still.
Yeah.
It's going to mess with this.
No, it won't.
We'll see.
Well, it shouldn't because we piped it into a file.
It goes through a cascade, so I can get one. But we can always just go to another dev.
That's fine.
Yeah.
So this is what by default a config file will look like. Within the config, we have what we would call the Genesis doc. And the way that configure works is you have an ability to build a singular TOML file that will include all the specifications for the chain and the accounts that you want to boot that particular chain with. You can also have, as we will show in the when we join the network chain or the workshop chain that we've set up, you can have these as two documents, which puts the Genesis information into a Genesis specification called a genesis.json typically, and then the particular runtime information for your particular node is kept in a config TOML. So we see here at the top of this config file, these are the accounts information that's relevant to the chain. So when the chain boots, it's going to have these accounts pre-configured on it. You can see that we have set up some validators in there. This is a pre-configured key that your system has generated according to the specification file. And then we have the runtime information. So you have runtime information around how Tendermint works. And as a little bit of context, Burrow leverages the Tendermint consensus engine under the hood. And so this is configuration information that Tendermint has for us. You can set up seeds, you can set up persistent peers, which we're going to show shortly. You can say what is the peer port that we're listening to. You can give it this node moniker so that the network knows what it's supposed to be. And also you can leverage the authorized peers feature. And thanks to Puric, this feature is shipped in Burrow. This is a feature that essentially allows anyone that connects to this network cannot sync with the network if the authorized peer feature is turned on. So essentially you can whitelist to only connect and sync to specific peers if you want. And then if you want to create empty blocks, you could do that, and then the interval for doing that. A lot of people along the road have been curious why empty blocks and blockchains are created. And the typical answer that we give is that it's a great heartbeat mechanism to make sure that your network is still configured, and it takes up nearly nil space, or certainly negligible space on disk. However, some people think that that's an annoyance, and so they have an ability to not create blocks if they don't want to. You can have, there's keys, RPC runtime information, logging information as well.
Can you remind me the gist of Tendermint as far as like finality and static or dynamic membership and stuff?
Sure. So it has transaction finality. So as soon as a block is added to the chain is designed not to fork. I mean, you can essentially hard fork that chain into a new chain, but the chain itself won't fork in real time. And so that's one of the big features of Tendermint is that it is a transaction finality. A lot of other consensus engines now have had it, but it was the first real consensus engine that was based on the idea of transaction finality. And that's really important if you have downstream systems that are relying on information from the blockchain. And the story of Tendermint's creation goes that Jay Kwan, who was the originator of the Tendermint project, was working for a Bitcoin exchange at the time, and he was really fed up with having to manage the forking and information downstream that he would put into his SQL databases so that they could run their exchange. And so that's why he came up with a consensus engine that was BFT and had transaction finality. The other thing with now I forgot the second part of your question.
Whether it's static or...
Static or dynamic, yeah. It is dynamic. We're going to show adding, all of us, we're going to show later how to join the validator pool for this network. So it's dynamic in that sense. Okay. Any questions on the config step? So now we have a configuration toml. It's a single file for this particular chain. And if you want to see the various features for Burrow configure, you can run Burrow configure help. The next thing we're going to do is start a blockchain here on a singular blockchain just running on your laptop. So if you want to take a look at the features of Burrow Start, you can just run Burrow Start help, and that will show you the various flags that you can use. Once you see that, then run Burrow Start config, quick config toml, validator index 0. Now, validator index is a feature that we use in local development in particular. And so what you're signaling here is for the Burrow node to read the Genesis object and to select the first validator within that object as what it should be running. We also use this when we're running clusters or when we're running chains and clusters to be able to stagger the key that they are using for signing. So this tells the Burrow node, even though you have access to X number of keys, to sign transactions and to act as a validator for you, you should use this particular key. And so this is an abstraction that we have around giving it a specific address to use. It reads its configuration object, it finds the address of in this case, 0 index 1, and it boots with that.
And worth saying that we have a separate notion of where we store the keys you have access to. So in this workshop, we're having Burrow self-host its own keys. This index relates to the Genesis document. So there's an array of validators in there, and it's saying be the 0th. And it will only be able to be the 0th if it can get the key that corresponds to. So this is kind of a helper thing for when you're running in these kind of contexts. Usually what we do is hard code the address. So in a cloud deployment, in the config, you can put validator address equals blah, or you can start with -a and explicitly give it that address.
Yeah, and if you had a passphrase around that particular key, you would add it in. And the other thing about running chains in the cloud is that often you have to do some finagling because an IP address and or port that a particular runtime thinks it's running on is often within a cluster is often very different from external to the cluster what it thinks. What other runtimes external to the cluster think is the runtime. In other words, if you give something a DNS address rather than an IP address, you want to be able then to say to this Burrow runtime, when I am advertising on the peer network what my address is, use what I'm giving you in terms of the external address rather than the IP address that I think I'm running on, because oftentimes, particularly when you're running in clusters, those can be very very different.
And one thing I think to note here as well, when I'm hearing Casey say it, is we are using address here overloaded. So the validator address is the 20-byte identifier of the key. So we have a bunch of addresses when we're talking about either EVM addresses, which are 20 bytes taken from, derived from the public key. And in this case, we're talking about validated addresses. Casey there is talking about actual IP addresses.
Yeah, good point. Okay, does everybody have a bunch of logs streaming on their screen? Does anybody not have logs?
Yeah. Right, yeah, this is the issue. So we need to run from a directory that isn't that chain's directory. I'm afraid we probably put a note on this. So if we...
because it's picking up the Genesis.json.
Yeah, it's kind of a bug. It shouldn't do that when it gets it from the config bit. All you need to do is move that quickspec.tom into it's easier. It might be easier to repeat. You're going to need the keys as well. So if you just read the command to make a quick another directory, quick. Sorry about that.
What was that?
So you need to
just change the Genesis.json to Genesis.json.back.
Yeah. Okay. That will just move.
Yeah.
Remove the Genesis.json.
We need it later. So
okay.
Move it somewhere. Yes.
Don't do it.
Yeah. We've used this same change directory. So in this directory, what you're going to have from the keys, from the spec, from the configure command, is the configure command is spoke to the key service you have running, and it generates some keys. The default location of those is in the .keys directory. This can be hosted elsewhere. So the assets we've got in there that we care about are the Burrow config and the keys.
So if I have stuff scrolling across my screen, am I good?
Yeah.
Okay.
You're good.
Yeah, I can usually just see from the shape. That looks nice.
Yeah, the shape of the logs. Yeah. After you read a lot of Burrow logs, you can you can tell if you're making logs or not by the shape.
You can detect what's wrong.
Yeah. Cool. Yeah, you'll get a big ugly new blog message, which is
Yeah.
Effectively, it's kind of JSON looking thing serialized into the log line. But this is a good point. If anyone's having any issues, it's not got to this point, you can maybe pause here. Or,
Yeah.
yeah. And if anyone wants to help,
Anybody need help at all?
Sean can help. Greg can help. I'm just taking notes. Yes.
All right. When you've seen a bunch of logs, you can Control C at any time.
So basically now I've run just one validator node by doing that.
On your laptop. Yeah, that's all we've done so far. Yeah.
Only one, right?
Yeah. This is just a local chain running on your laptop completely.
Yeah, and basically the validator in text 0 takes the first, that's basically where he gets the keys.
Yeah.
The basic.
Yeah. So it reads so in the config, there's no key contained in the config, but it takes that address and says let's start as that validator. So it's a quick and dirty way to start a local chain job testing.
If you wanted to do it the right way, then you would have your key somewhere else, and then you would provide that as
Yeah.
if you wanted to.
So what we'll see when we generate the key is we'll run Burrow's key service as a standalone.
Yeah.
So we'll do a Burrow key server. That is designed so you can either run it co-located with the node, you can run it self-hosted in the node, you can run it against a centralized machine within a particular validator pool. So, and ultimately that's an interface that is hiding the notion of a HSM or something like that.
Yep. And so when you're developing locally, the second line on the screen there, Burrow spec F1 piped into Burrow spec configure, piped into Burrow start v0. That's one liner that will start a Burrow node instantly. Well, not instantly, but close to instantly. So when you're developing locally and you want to go through just, I want a blockchain so I can work on contracts against it, that's a one-liner that encapsulates everything that we've done so far, literally.
And so, is it pipe symbol missing? The pipe's missing there after the Burrow spec 1SF1. And the other thing to note,
Where?
It's in the first instance.
Oh, sorry, it's on my screen.
it's scaling.
Yeah. Sorry about that. It's Burrow spec F1 piped into. That's a screen issue. Sorry.
And then when we're running this, we're not actually saving. We're going to be accumulating Burrow state, which includes registration of the hash of the Genesis, various other things. If you were to run this again in the same directory, it's going to pick up the existing Burrow state and freak out. Yeah, so if you're ever doing it this quick and dirty way, then you need to just go to delete.burrow. And on that note, if we ever want to get back to reset our state, we can delete.burrow. That's where all the chain state goes. That should be a relatively safe operation to do, provided that state is somewhere in the network if you care about that state. Otherwise, you would rewind to 0.
Which is a nice segue into the next thing we should do, which is remove the .burrow directory. So just Control C to make sure that the Burrow runtime is not going, and we're going to now remove the .burrow directory because that was just to show you how to boot a simple chain on your laptop, and now we're going to all, hopefully all join the same network. So,
I'm going to watch validators as people
So there's a couple of steps here that we're going to do to join this network. Now, in the Git repository that you cloned are a configuration file, and as we've seen before, genesis.json file. Before we go any further, if you moved the genesis.json file to genesis.json.back or something else, move it back into being genesis.json. So within the change directory of the workshop directory, you should have a burrow.toml and a genesis.json.
So unback it.
Yeah, unback it, exactly. Because now we're going to join the collaborative network. So about an hour ago, yeah, go.
Where's the .burrow folder?
It should be in the chains. It'll
Chains?
Yeah, by default, it'll create it as in the current directory that you are.
And it'll be hidden because it's a file generally.
So because this is kind of just meant, because this is meant to be a tour of the Burrow features. Now we're going to talk a little bit about the Burrow key server. It is a signing server. We will be hopefully moving it to use Ursa as that project continues to mature under the hood. And what it is a simple HTTP wrapper around signing and verifying, generating, and other key management issues that you have. And so if you run from the chains directory, if you run Burrow keys server, and then with the little ampersand to background that process, that will start this key signing and key management server that we have built within the Burrow binary. And then you can run Burrow keys gen. That should be -n and then -- name, and then give it whatever name you want. Within the Burrow keys directory, we have a naming convention that we use. And that naming convention essentially maps a particular name of a key to a particular key's address. And it makes it a little bit nicer to develop in some of the other features that we'll show along the pathway here. And then at the end, run pkill Burrow to stop the Burrow keys server. And so for context, what we're doing right now is we're creating an individual key that the validators that we're all going to become on this network will be using locally when you join the network. So this will be your validator key on the network. Any problems so far? Anybody have errors? Anybody?
So that key is a private key, right?
Yeah, well, it'll be public and private key, yeah. So if you go in, if you want to see what the keys look like, you can, they're in the .keys directory under data, and when you generated a key, it should have given you a 20-byte hex key address. And we're going to want to keep note of that, at least keep it in our terminal so we can copy it.
The output of that gives you this string.
Right, yeah.
That's the private key.
That's the address. That's the address of the public key. What was outputted was the address of the public key. And so if you cat .keys/data/that.json, you can see the whole key. It's a JSON object. Or it's a JSON file.
Inside of that key server.
Yeah, exactly. And you can, when you run Burrow keys server, you can run it against various directories. There's a flag for doing that. So if you want to use some different key directory, when you're generating the keys, you can do that as well. All right. Anybody not caught up and not have turned off their key server? Cool.
The reason we're taking down the key server, by the way, is that we're going to run this self-hosted mode. So we're going to have port collisions and whatnot. We could do a more complex setup and run keys in the background.
Yeah. Okay. So now we're going to start a node and join the collaborative network. Before about, 30 minutes before the start of this, we used the Helm charts that we have published to boot within our Kubernetes cluster a simple 4-node chain. So we're running in our cluster a 4-node blockchain, and then we published the Burrow.toml and Genesis.json object when we instantiated that chain into the chains folder of the workshop repo that everyone cloned.
Before we get ahead, there's a little wrinkle here. So if we could open up the Burrow.com, we'll see there's a moniker listed at the top. Now, the problem we had at the beginning here was that was set to nothing. I have set it to a default, but it would be helpful and possibly, I think it interferes with the peer exchange. If we could all set that to something reasonably original. It shouldn't matter if there's a clash, I don't think, but we'll be able to identify each other on the network. So if you open up Burrow.toml in a text editor, you'll see there is a tendermint section at the top, and then there's a moniker. And I think it should say, if you pulled recently, it should say you're validated here. If it's empty, you definitely need to set it at least. Otherwise, your connection will get dropped, which is new, in fact.
Was it Burrow Dash Workshop?
Yes.
Yeah, sorry.
Something original. Yeah. We'll see whether what's the birthday paradox at work here.
So the moniker is right here in the Burrow.toml. That is line 7, if it's not super clear.
So add anything in there? Anything?
Yeah.
I wonder if people are able to, I know that people have Hyperledger Rocket Chat accounts. I may dump a few commands in the Burrow room in there.
That's a good idea.
Just for a little bit of network introspection stuff you can do. So it's just Burrow. chat.hyperledger.org/channel/Burrow.
So a few things that you're looking at here. Predominantly the persistent peers. So when you're connecting to a network that is just not a single node network running on your laptop, then typically what you will do is you will have a relatively static node or nodes, and those you would use as your persistent peers. And they would be relatively static because you wouldn't want to be running those on a laptop. It would be hard to then connect into the network. So what we typically do is we'll run a few nodes in a cluster. We will give them an external address and we will give them a DNS entry. And so you can see here that if I can operate not my laptop. You can see if you cat the, there we go. I used to like your laptop before. There we go. Okay, so you can see that we have a hexadecimal address and then and then just a URL. So we gave it this URL this morning, and then we gave it a port number. And then there's 6 of these that are in here. And what you're looking at is the hexadecimal string that is after the TCP and before the @ what that is the peer-to-peer key that particular node uses. So validator nodes by default leverage 2 keys. They use one in terms of their peer-to-peer identity and then one in terms of their signing identity. This is for kind of a range of security reasons, as well as the fact that the key types that Tendermint uses by default for signing are not very good for handshake exchange over the net. And so technically the key that we have generated is, if anyone is interested, is an ED22519 key, and this is a elliptical curve Diffie-Hellman key that we use for the peer-to-peer addresses. And so this is a long string. You can see it in your terminal window. We have linked everybody by default to 4 nodes. But the basic idea is if you set one node in a particularly static place and you get its peer key as well as its IP address, then in your other nodes that you're connecting into it, you give those as persistent peers.
And we're just experimenting now. Now, in principle, there's a peer exchange routine that runs here. So it will take your advertised external address, which can be sent in config, but will be detected in some circumstances, and it should share that. Now, I haven't seen that happen just here, so we're having a little test to see if we explicitly give our local address. So we should be able to make connections across the local Wi-Fi network here. So I'll let you know if that works. If it does, what we might need to do is look up our IP addresses, put the IP in port, the external address in the Burrow port, but we can stop and start.
Yeah. Okay, so if you're interested, you can cat the genesis.json, and you'll see that it's a little bit of a longer JSON object, which looks very similar in nature to the fields that we put up in the single node config file that we had before. And so now what we're going to do is we're going to start the node and connect into the network. So get ready for the hopefully the big bang that will actually work. Burrow start with the address flag, and then paste in the address that was outputted when you generated your key. We then should see a bunch of nodes connect into the network.
So, yeah. So you don't need to restart the key server, right?
No, you don't need to restart the key server at all. The Burrow node in its config file will be given a directory of keys that it should use, or it will be told to use an external key signer. So if you were running on an HSM or something along those lines, you could tell Burrow, okay, you're not signing. This other system is going to be signing. But for the purposes of this, we're just going to use the local keys that we generated on disk. And so that is all pre-baked for you. And so, but we need to tell it which address to use within the keys directory. And that will be the key that you generated earlier. So when you did the keys gen command, it should have outputted a string. Just copy that and paste it after the -A for account, or sorry, address. And that should connect you, well, that should dump a lot of logs, because Burrow's logs are very chatty. And then it should connect you into the network. You good?
Scrolling along.
The changes in the network are empty blocks being created?
Yeah. You should see a bunch of empty blocks getting caught up here.
And it's like that all the time, creating new blocks?
Yeah, so I showed earlier, there's a setting within the config file that you can change to not create empty blocks, or you can expand essentially the timeout. So by default, Tendermint, we observe Tendermint on ish smaller networks, so say less than 20 validators, typically makes blocks at about a 1.3 block time. By default, it targets a 2-second block time, but in reality, we see most blocks come in at about 1.3 seconds. So that's, it'll make blocks by default somewhere around those lines. It depends on your network setup as well. So, cool. All right, now let's do something. So now we are all running on the same chain. And from here on out, I'd ask you to open a new terminal window, because we're just going to let this Burrow node connect into the network. We're going to leave it running in the terminal window where it currently is. And we are then going to run all the commands going forward in a second terminal window. Is anybody having any problems with the Burrow start? Anybody not see logs and blocks coming in? I'm just going to back up here in case you need to see the commands again.
So does it have to fetch all the blocks before it?
It's syncing now. Yeah.
Okay.
before you can validate, you can still talk to that chain, but before you can validate.
But would I see it listed in the list of nodes with that curl command that Silas gave?
Yeah, I don't know which command he gave, if it was netinfo or validators. If it was netinfo, yes.
Netinfo filtered by some peers. So,
Yeah.
so what we're seeing, we're just having a little look on, just experimenting now with whether we can get. So I think if everybody is to add me as a persistent peer, I think that I will then act as the peer exchange gossip for here. Those nodes, when they try and connect to any of us, it's going to fail. It will mark it as bad, so it won't enter the peer exchange. So if I'm on there, then I think I'll end up acting as a hub for the peer exchange. And that requires the line that I've just put in there, so you could try that now. It just replaces the persistent peers and it adds me onto the end. The key address you see there, that's the node key. So there is a peer, there is a key that is used for peer-to-peer, station-to-station projects, like peer-to-peer TLS type thing. Well, in order to connect directly, you need that ID. When the peer exchange takes over, once you know someone who's safe, then it starts spreading it around. So that should be enough, but we're just testing that.
Okay, so in the terminal window where your Burrow runtime is running, just Control C. Now you're not going to. This is actually good that we're stopping the runtime. Now everything is saved to disk. We're not going to remove the .burrow directory. So even though your node is syncing a bunch of old empty blocks, you won't lose those. And if you, once you've stopped your Burrow runtime, if you open your burrow.toml in an editor and replace the existing line, line 7, I think, the persistent peers line with what Silas pasted in the Burrow room or the Burrow Rocket Chat room. So just replace that line, save the file, and then rerun the Burrow start command. And if anybody needs help doing all that, we got a bunch of people.
We push it to Burrow well, the trouble is that we've all made a few changes there. We need to have a situation where we can share generic config. So we've got the moniker. You can set the moniker in the command line. To be fair, that's what I should have done rather than getting into Reddit.
Yeah.
Also, I've been informed probably that there is a flag in Tendermint that is probably going to just not appear exchange overloaded addresses.
People back to running in Burrow? I don't think so. Give it a few more minutes.
So we are now essentially running the blockchain between ourselves, right?
Yep. Yeah.
Because I'm pretty good with Linux and command line, right? But still floating around with the concept sometimes. You know,
yeah. So now what's happening is we are all persistent peers. So we are all peers on the network. What we are not is participating in the validating pool right now. So we're going to do one more thing, and then we're all going to make ourselves validators on the chain.
So do I run the start again?
Sorry?
Do I run the start Burrow?
Yeah, run the start again.
Same address.
With the same address. And so Burrow will be running. And so now what we're going to do is to interact with this chain by deploying a new contract. So within Burrow, we have a Ansible-like system that we call Burrow deploy. And this system essentially allows you to declare how you want to deploy, call, query, nearly everything that you want to do with a package of smart contracts you can do within the Burrow deploy system. And what it is it reads from a particular YAML, and then it executes those commands how you have configured them. Now, we haven't given a Burrow or a deploy.yaml in the system because part of this workshop will be to explore a little bit the Burrow deploy command and to build our own deploy.yaml. So if you change directories into the 04 deploy directory and you cat the little Solidity file that we've added, you'll see a file that I have the wrong fingers for your... So this is a very simple Solidity contract. Has anybody never seen what a Solidity contract looks like?
Now they do.
Okay, now you have. So the way that Solidity works is a little bit like a strongly typed JavaScript language in terms of its notations. And you can see here that we have declared a contract object. We've given that contract object a name. And then at the top line there, what that's doing is declaring a variable that is an unsigned integer. And then we have two functions in this contract. The first function is a set contract, and that is given an unsigned integer, and it stores that in the declared variable. And then we have a get contract, which then returns the set variable to you in the runtime. Okay, and so we use this pattern of contract in a whole range of testing because it's about the simplest way that you can do to test the paradigms of the two things that you typically want to do with the Solidity contract, which is get a variable that has some business logic, that does some things, that stores some things, and or query information out of the state of a particular smart contract. So now becomes the question of how do we interact with this. Now, not to give folks exactly the answer because I can't work the mouse, but to better actually because I'm really bad. I'm incompetent at touchpads. So here is what a very typical Burrow deploy or deploy YAML may look like. And so in an editor, you'll want to open up an editor and create a Burrow deploy, or sorry, a deploy.yaml file. And then you'll want to fill out a few of the fields. So at the top of the system, you give it an object called jobs, and then that's going to be an array. And Burrow deploy is going to then go in order of the jobs that you give it. So each of the jobs within the array contains a name that we will be using later, and then the type of job that it is. And within the documentation of Burrow, which is godocs, oh, sorry. So all the Burrow documentation is apparently impossible for me to do.
Sorry?
All the Burrow documentation is in godocs, which is godoc.org /github.com/hyperledger/Burrow. And we're in the deploy package. And within the deploy package, you can, if you scroll down, you can see the various things that that these objects, that these jobs can do. So we have jobs that that handle management of the accounts. So if you're within this sequence and you want to do something from a particular account, then you can essentially say, use this account going forward until I change the account. This is helpful in testing when you want to maybe deploy a contract via one address and then test an actor, another actor within the system. And so you give it the account job, change the account, and then do other things as that account. We have a simple assert system that allows you to use Burrow deploy as a test bed. It's not a full-featured testing sequence. Typically, how we deal with things is we run our tests from Solidity, and then we give simple returns from those test contracts, and then we'll do an assert command at the Burrow deploy level, essentially return was 0, and that allows us then to understand that the in-chain sequence operated as it should, or did not operate as it should. We have a build job, which does simple, we haven't done Sol C, have we?
Oh yeah, we forgot about that. Okay.
We forgot a pretty crucial thing, which we're going to have to do here shortly. Sorry. We haven't done the build. We have a build job, which will compile your contracts. A call job. Within Ethereum-based systems, when you want to interact with a contract at the function level, this is typically called a call. And so this is a transaction that will change state. And so this is and the way that you generally do this is you say, I'm going to do a call transaction, which is a specific type of transaction within most Ethereum-like systems. You give it the contract that you want to talk to, the function that you want to talk to, and the data that, the function parameters that you want to send into that particular function.
So Casey, if you open up Hyperledger chat on there, actually, just on the browser, chat.hyperledger.org, I've just sent the link to the appropriate Solidity version for people to grab while we do that. If you get Sol static Linux for Linux, you just need to download that chmod +x, and that's the executable.
Yeah.
That's the easiest way to go. You may have Solidity in your package manager, we don't know what version you get. It's probably a little easier to get that and get it on your part.
Yeah. Then we have a deploy job, and the deploy job is a higher level abstraction around build. So by default, deploy will compile the contract and send it into the chain. And you can see as we go through here, there's a whole range of different settings within the various jobs that we can do. We have a meta job, which allows you to layer these YAML files in. So in our system, Blackstone, which is like 20,000 lines of Solidity code and somewhere around 13,000 lines of documentation, we have, I don't know, 25 of these different YAMLs to do deploying and testing. And then we use this meta job to make it a lot easier for our CI system to manage all of those things. We have a permission job, which allows you to modify the permissions of specific counts within the chain, give them, remove permissions if the key that you are using has permission to change others' permissions. In other words, does it have essentially root permission on the chain? We have the proposal mechanism, which I talked about earlier. The next major one that we have is what we call query contract. Oftentimes you want to interact with a Solidity-based or an Ethereum-based smart contract, and you...
Sorry, can you put chat up and just put in the map details for people there? Yeah, so map is 100.
Yeah.
Just leave it up so that and then people can... Oh, sorry.
Yeah. That's going to install 051 though. I think this contract should work fine against 051.
There's no planner on it, so
Yeah, it should be fine.
yeah, yeah, sure it is. Is it not? How do you do a different version?
Okay. So query contract is a way to get information out of the state of a smart contract without actually modifying that state and without sending a transaction into the blockchain itself. So we're going to use this when we call the get command or the get function, and then you can use the inbuilt name registry to do names. You can interact, you can send tokens if you want to, and a few other jobs that aren't really high value. So if everybody wants, you can build a Burrow deploy.yaml that looks something like this. At the top, you'll want jobs : to start a jobs object. Then you will want to have name the job. Then that job will be the deploy job, and the contract with the contract, which would be different in our case because we want to use the get -set .sol contract that is in there. Then we're going to interact with the contract via a call job. You can give it a name of whatever you want, give it the call job, and then you can give it the destination. So the destination is the contract that you are doing. And you can see here in destination we have $, deploy storage K. Now this is a variable expansion that we use, and so what this is saying is call the contract address that was returned by the deploy of the previous job. So the $, is, as often the case, is a variable expansion. And we're going to call the function that's called set. With the data, you can give it 5 or 10 or whatever data you want to give it here. Then you want to run a query to query the get function that will return to you a number that is stored in the variable. And then you'll want to run an assert that the query storage, which is the result of the previous job, equals the number that you gave it before. So if you want to set a variable and then use that throughout your sequence, you can use the set job as well. So we haven't given you one of these deploy YAMLs. You'll need to do this, or you can essentially copy and paste from maybe Silas. Can you dump the URL for this file? This Burrow deploy?
Yeah.
Can you show the deploy commands?
Sorry?
Can you show the deploy command once, please?
Yeah, we're going to do that in a minute once we have this YAML on our within the 04 directory. So we should be in the 04 deployed directory, and we have a Solidity contract in there, and now we're making this deploy YAML. And you can change this up however you want, whatever makes sense to you. You can change that number around. You can change the ordering if you want. Probably doesn't make a lot of sense to change the ordering in that this is really simple. But the sequences here are in this deploy YAML. Again, we're deploying a contract onto the chain. We're calling a function from that contract. And we're doing this in plain language. Then we're querying the same contract to retrieve something that is saved within the state of that smart contract. And then at the end, we're running an assert to make sure that the variable I got out of the contract was the same as the variable I put into the contract. So high level, that's what's happening. And we dumped a link in the Rocket chat to this. So if you're a copy and paster, feel free to copy and paste. All right. When were we supposed to coffee break?
Coffee.
Sorry? 10 to 4. 10 to 4, okay, cool. So we have about 20 minutes left, and we're going to get through deploying this, and then when we come back, we're going to do the next thing, which is make ourselves validators on the blockchain. So even though we have a running local node, we're going to interact with it, even though we're not a validator on that chain. And show how that works. And then once we've interacted with the chain via Burrow deploy, then we'll all add ourselves validators. Now the reason that we can do this is because the Silas probably copy and paste this deploy command because they all want to type that. No one should ever have to type that address.
No, I think it's a rite of passage.
Sorry. So we, within the repo that you cloned, we put a key, and that is the BE60 key. And when we configured this chain, we gave it root permissions on the chain, and you all have that same key. Now, obviously, this is a horrible idea in a real-world environment. You would never put a key in a repository unless you were solely using it for testing or CI purposes. But in general, it's going to help this sequence that we're going to go through next. It's semi-irrelevant for this portion of the sequence. But next, when we add ourselves onto the validator pool, we're going to use the BE60 key, which has been configured as having root permissions on the blockchain. You can think of these as network level pseudo permissions, and that means that it has an ability to change things within the state. And we'll go through that when we come back from the break. Does anybody not have some semblance of a Burrow.yaml? Or deploy.yaml, sorry. Okay.
What step is going to invoke SolC?
The one we're about to do right now.
Okay.
Oh yeah, and sorry, and you'll want to have SolC installed in your path.
It's downloading.
So an absolute brutal question, right? So .sol is a Solidity function, right?
Yes.
And YAML, what is that? It's just they deployed the YAML, what is that?
Right. So deploy.yaml is, what I just showed an example of. Here, yeah. So what the deploy.yaml is, you'll need to create it, but it looks something like that, and it is an interpreter. So we have within Burrow an interpreter that runs through these steps that you have given it in order and does the things that you have told it to do.
And it is...
It's essentially a way to manage the deployment of sophisticated systems onto your chain in a way that you can reproduce it very simply and easily. This is a legacy. This has a legacy to go back that goes back to the very first thing that I ever built that was Ethereum based in March of 2014, where this has evolved, but at the time was called Ethereum Package Manager, and it was really built to operate kind of along the same lines as how NPM operates, but you want to do different things when you're talking about a smart contract enabled blockchain than you would do in just install locally packages that are hosted remotely. There's different things you want to do, and so this has evolved over time. But what you're seeing here, the deploy YAML is essentially a DSL that we have created that makes our lives easier when we're dealing with pretty sophisticated smart contract-based systems.
It's pretty useful, but evolved is the word, I think.
Sorry?
It's pretty useful, but I think evolved is the word. It's got a lot of mixture of features.
Yeah.
What are you trying to do with the linkaps subcommand of Burrow?
I just got
linkaps.
link app. Did I paste that?
Yeah.
Who knows? I just copy pasted. That's what's on the Solidity page. I don't know. Yeah,
Okay, so two things before we go forward and do the Burrow deploy. Does everyone have SolC binary, which is the compiler for Solidity, installed? Silas put the instructions on Rocket Chat. That is our fault. We should have caught that earlier in the dependencies phase. I'm really sorry about that. So we have two ways when we run a Burrow deploy. We have two ways in which we can think about signing the transactions. By default, we use what we call mempool signing. And mempool signing says, I'm going to send a Burrow node to a Burrow node a package of things to do, and I'm going to expect that that Burrow node will have an ability to sign the transactions on my behalf. And it will have the right address that I should use. Now, mempool signing is separate from the addresses that you will use. And essentially what it says is where is the signing location of the binary that will sign. In more sophisticated signups where you have divergent signing binaries and Burrow runtimes, you can give Burrow deploy a signing address to use and a chain URL to use, and In that instance, what it will do is it will formulate the transactions, send to the signer, receive the signed transaction back from the signer, and then send into the Burrow network the actual signed bytes. The sequence that we're going to go through here, the Burrow deploy system will pre-package the transactions, and it will send to Burrow and say sign with this particular key, the BE60 key in this case, and then send into the mempool for processing by the validators. Okay, so if you have the Sol C binary, feel free to run Burrow deploy with that command, and that's a long address. So Silas put it in the Rocket chat, so you can copy and paste it there.
I'm afraid I'm getting a bit of like support happening in the Rocket chat. It's not the support from the kind of person who seems to RTFM much, or RTF their own code in much.
Pardon me. And so this command will has pretty extensive error messages if anything goes wrong. If you see at the end of running the command writing to deploy.output.json, that means that everything accomplished directly. Now, to be clear, what we're doing here is we're going to be sending a whole range of the same contracts into the chain, and we're all going to have our own version of this contract, and it's all going to be at the same address, but we're all going to be working on the exact same chain. So all of these contracts will be all there.
Where were we supposed to get storage.sol from?
Oh, just change that line. It should be, that should be get set in the deploy YAML.
And then, yeah.
Yeah, that should be get set. Get dash set. .sol. Okay. Yeah, that should be in the.
Oh, yeah, yeah. Okay, that's the answer.
I think for tomorrow we'll give people the YAML. Because making your own YAMLs isn't particularly fun for anybody.
I guess like at the set storage job,
Mm-hmm.
you guys done here for a while. I'm not sure what's going on.
Should have now.
Silas in the last version of Burrow decided to set a timeout on this that was about 1,000 years, I think. So
that's no, your node is gone down again. Now, just restart the node, delete .burrow. We have a tiny bug at the moment whereby if you restart your node and you just got a transaction, it breaks everything off. It's a checkpointing issue, so I think if you're restarting whilst the transactions are flowing on this chain, you may have hit that.
anybody else have problems? Yeah.
Just delete .burrow.
Just a question. So where is the data that's
This one.
It's all in .burrow in that local directory.
in the directory that you run the files?
Yeah. So it chains for this chain.
The last command in the group, the list of commands that we had sent by Rocket chat. That is not working, so I'm not able to run the next group in caps.
to get this?
This, that was the,
Okay, just go back to your terminal quickly.
I read that the government was removed.
Oh, really? Okay.
I think Solidity did an update.
Okay, that's fine. Just do Sol C space C. Sorry, Sol C. No, one word.
Because this is a file that
Space dash version. Yeah, so you're good. You have Sol C. That's all we need to make sure.
It is still up and running in a separate window, right?
Did you have a question, Mira?
Oh, does it take a long time to deploy the contract?
Shouldn't.
Yeah, okay, so that is a file in your keys.
If you've got no transactions,
If you have it before, I removed the
last transaction, then if you issue something in transactions,
From give me that error.
Okay, right. So open the deploy YAML in it editor.
It hasn't given me the error yet.
And then change storage.sol to get-set.sol. Save that and now rerun it.
it's wrong that hash, that was the thing. So it's basically that it's committed transactions.
Yep, great.
Anyways, from the start. Yeah, I have failed this. I might actually do this.
Sure.
Yeah, so I'll go to your website.
We tweeted out the slides, but so when we go to break here, I'll give you the link to the slides. Okay. And you shouldn't be too bad.
Go into your chain.
I think I missed it.
Oh, no, you're good.
Oh, Sean, I need you again. Sorry.
can you also share the link to the slides on the rocket chat so that we can refer to them later?
Yes, that's a good idea, actually. Let me do that
I
now.
have set a very long timeout. Just kill this and try it again. I don't know quite what state we ended up in here. I accidentally, in the current version of Burrow, I have like 100-second timeout where it should be 10. Sorry about that. Yeah, that process is zombied out somewhere. So the issue unfortunately you have is if you are restarting the chain, now there's a transaction volume.
Oh, thank you. Because I really
If you leave the chain running, it should work fine. If you have an issue, just delete it off Burrow and bring it back up. This is something that I'm going to probably fix tonight.
No, network.
Yeah, okay, great.
Okay. So basically, let's take a break now. If the contract hasn't deployed, no problem. We can help you during the break. And when we come back from a quick break, we're going to move on to increasing the validator pool and resiliency of this chain by all becoming a validator. So break time unless you need help.